Okay, so today we're going to wrap up our chemical reaction unit. The last thing we're going to learn about is something called net ionic equations. Before we learn how to write a net ionic equation, we have a couple building steps first. Okay, so the first thing we're going to do is we're going to learn how to write something called the complete ionic equation. In addition to complete ionic, sometimes you'll see it as the total ionic. Okay, so complete ionic equation or total ionic equation. So this equation, it just shows all of the dissolved ions in those ionic compounds. So we're going to use this repeating example over the next couple slides. So go ahead and copy down this equation. So we have silver nitrate plus sodium chloride gives us silver chloride plus sodium nitrate. Okay, so go ahead and copy that down. This will be like our reoccurring theme. Okay, so we're going to write that complete ionic equation together. So our first compound is silver nitrate, and it's aqueous. What does it mean if something's aqueous? Okay, it's soluble. What does it mean if something's soluble? Okay, it's going to dissolve in liquid. So what that means is it's going to break up into its individual ions. So the bond between silver and nitrate, it's going to break. And you end up with the silver ion and the nitrate ion. Okay. So if I'm writing this in purple, you write this with me. All right, next, we have sodium chloride, and it's aqueous. So what does that mean? What does it do in liquid? It's going to dissolve. So sodium chloride is going to break up into sodium ions plus the chloride ions. Then we have silver chloride, and it's a solid. So that means it's going to stay together in water. So I'm going to keep it together in my equation. So I'm going to write AgCl, and it stays bonded. And then finally we have sodium nitrate, which is aqueous. And what does aqueous mean? Okay, it dissolves. So that means it breaks up into sodium ion plus nitrate ion. So this equation that I have up here in purple, this is what we call that complete ionic equation or the total ionic equation. In the word ionic, do you see ions? Okay, so this is showing that total equation that if they break up into ions in solution, you're showing each and every individual ion. Okay, so then the next step is to identify something called a spectator ion. Before you just mindlessly copy, let's just look at the word spectator. What's a spectator? If you're at a sporting game and you're a spectator, what are you doing? Okay, you're watching, right? You're on the sidelines, you're just watching. Are you participating? No. So spectator ions, they're ions that aren't directly involved in the reaction. They're just hanging out, okay? So this is how we're going to identify them. This is the same reaction that you just wrote down, so you don't need to rewrite this equation because this should be identical to what you just wrote on your paper, yes? Okay, so then spectator ions, they're going to look identical on both sides of the reaction. So what we're going to do is I'm just starting on the left side. So we have silver ion, so with the plus charge. Does it look identical on this side? Or does it look different? It's different, right? Over here it's silver ion, and now this is bonded to chlorine. So different, so not a spectator ion. So then we move on. So this is nitrate, NO3 with a minus charge. Does it look identical on this side? Okay, so I'm just gonna underline that. So that is an example of a spectator ion. It looks identical on both sides of the equation. All right, next we have sodium with a plus charge. Sodium with a plus charge, are those identical on both sides? Yes, so then yes, it's a spectator ion. And then we have chloride ion and then chlorine bonded to silver. Is that identical? No, right? So it's not a spectator ion. Okay. So spectator ions, they look identical on the left side of the equation as they do the right side. Okay. So now, just very lightly, go ahead and cross out those spectator ions. So then what we have left is what we call the net ionic equation. So now if we just rewrite the equation without those spectator ions, so write it with everything that wasn't crossed out, we should end up with silver ion plus the chloride ion gives us silver chloride. And so the net ionic, this is like the important part of the equation because these are the only things that actually react and make that new product. So it's kind of like simplifying the equation to the only ions that are actually like doing anything important, okay? So if you look at your previous equation, like once you cross out your spectator ions, do you see how this is what's left over? Okay, so then this is the net ionic equation. So this one should be short, simple, and it just tells you what actually makes that solid. Okay, last step, just make sure everything is balanced. So when we look at the net ionic equation, you're always going to have ions on at least the reactant side. So we just want to make sure that the elements and the charges balance. Okay, so there's one silver, one chloride, one chloride. Okay. On the right side, there's no charge, so silver chloride is neutral. And then on the left side, you have one positive and one negative. Do those two neutralize? Good. Okay, so you just want to make sure everything's balanced. In this case, is everything like naturally balanced? Okay. Okay, we're going to do two examples. Okay. So here's our first example. Go ahead and write this one down. So we have lead plus silver nitrate gives us silver plus lead nitrate. First, just for review, what type of a reaction is this? Okay, good. Single, so you can write net ionics for single and double replacement. All right, so the first thing we'll do, we're going to write the complete ionic. I'm just going to write CI for short. Okay. So the complete ionic, this is the long one. So we're going to write down all those ions. We're going to start with lead. It's a solid, so that means it's going to stay a solid in solution. Okay. So that one just stays the same. Then we have silver nitrate. That's aqueous. What does aqueous mean? Okay, it's going to dissolve. That means we have to break it apart. So it breaks up into silver ions plus nitrate ions. For products, we have solid silver. So since it's a solid, we just write it as is. And then we have lead nitrate. And it's aqueous. So what does aqueous mean? Okay, it means it's going to dissolve. So we have to break it up into the ions. So we get the lead ion plus the nitrate ion. And then lead's an ion, so we have to figure out the charge. Lead is one of those special elements that can have multiple charges. So we have to do just a little bit of problem solving to figure out what's the charge of lead. Okay. Do we know the charge of nitrate? Okay, so nitrate is -1. And how many nitrates are there? 2. What's 2 times -1? Okay, so what does lead have to be to balance that? Okay, so we know lead is that +2 charge. So if you're ever given like a transition metal with multiple charges, you might have to do a little problem solving to figure out the charge. Okay, so this one, your long one, that's our complete ionic. And then now we want to simplify that to the net ionic. Okay, so we're going to go through and we're going to cross out all those spectator ions. Okay. So here we have solid lead and lead ion. Do those look identical? Okay, nope, so not a spectator. We have silver ion and solid silver. Do those look identical? Okay, nope, so not a spectator. We have nitrate ion and nitrate ion. Do those look identical? Yes. Okay. So if they look identical, go ahead and cross them out. So then the net ionic equation is just everything that isn't crossed out. So we have solid lead plus silver ion, and that gives us solid silver plus lead ion. Okay, you with me so far?
Yes.
Okay, the last step, everything just needs to be balanced. So elements and charges have to be balanced. So if you look, our elements are balanced because it's just one lead, one silver, one silver. However, the left side of the equation has a +1 charge, and the right side has a +2 charge. So are the charges balanced? Okay, so we just have to balance the charges. So you're still adding coefficients. Okay, so we need to get this side to a 2+, so what coefficient has to go here? Okay, so we'll put a 2 here. Okay, so now we have 2 positives on the left, 2 positives on the right, but now we have 2 silvers, so what do you need right here? Okay, just a 2 there. Okay, last example one. This time I just give you the reactants, so we'll have to predict products, then we'll do that complete ionic and net ionic. So we are taking calcium hydroxide plus iron 3 chloride. So before we predict products, do we need to know what type of a reaction this is?
Yes.
Okay, yep. So if you look at it, what are you starting with? Well, like what are they elements? Are they compounds? Okay, you're starting with 2 compounds. So what type of a reaction is that? Okay, so double replacement. So that means that calcium and iron, they're going to switch places. So calcium is going to bond to the chloride, and iron's going to bond to the hydroxide. All right, so we know calcium's going to bond to the chloride. Can we just go CaCl, put them together, and call it a day?
No.
Okay, what do you have to do? Okay, we've got to balance the charges. What's the charge of calcium? Okay, calcium's a +2. What's the charge of chloride? Okay, if you crisscross, what do we get for that formula? Okay, so we get CaCl2. And then iron is going to bond to hydroxide. All right, iron is a transition metal, so we have to figure out the charge of iron. So we're going to have to use this to figure out what's the charge. Do we know the charge of chloride?
Yeah.
Okay. Chloride is -1. How many chlorides are there?
3.
3. So what does iron have to be to balance that out?
3.
Okay. So you have to do a little problem solving. So iron is a +3 charge. Where would you find the charge for hydroxide?
On the back of your reaction.
Perfect. Your naming chart. What's the charge of hydroxide? Okay, -1. So if you crisscross, what do you get? Okay, so you should be getting FeOH3. Okay, then solubilities. Okay, so get out your solubility chart. We'll do calcium chloride first. So remember, you go off the anion. So find chloride. Okay, so once you find chloride, is calcium one of those listed elements or ions? Okay, so it falls into any other. So what's the solubility? Soluble, that means it dissolves. So we're going to write AQ. All right, then we'll look up the iron 3 hydroxide. So find hydroxide. Is iron one of those listed ions? Okay, so then it falls into the any other. And what's the solubility? Okay, insoluble, it's so hard to see, but you should have an S there. This should be an S. Okay. Next, my advice when we have double replacement reactions, balance the equation before we do the complete ionic and the net ionic. Okay, if we balance it now, it makes it easier later. Okay, So let's go to balance. I would start with the hydroxide. So there's 2 on this side, 3 on this side. What's a common multiple? 6. Let's try to get both sides to 6. So I'm going to try a 3 there, and I'll try a 2 here. Okay. All right. Then we have 3 calciums. So what do we need right here? Okay. I'm going to try a 3 there. So you have 3 calciums. 3 calciums. 3 times 2 is 6 hydroxides. 2 times 3 is 6 hydroxides. This side there's 1 iron, and over here there's 2. So what do we need right here? Okay, so I'm going to put a 2 here. Okay, so 2 irons, 2 irons. 2 times 3 is, okay, so 6 chlorides. 3 times 2 is 6 chlorides. Are we balanced? Okay. So if we do all this work up front, writing the complete ionic and the net ionic equation should be much easier, okay? Okay, so complete ionic, that's when I'm going to break apart anything that's aqueous. Okay. So calcium hydroxide, it's aqueous, so we're going to break it apart. I'm going to keep like my quantities to keep it balanced. So how many calciums are there? Okay, so we're going to have 3 calcium ions. Okay, now watch this next step. Our next ion is hydroxide. How many are there? Okay, 3 times 2 is? Okay, so watch how I write this though. I'm just gonna make it 6 hydroxides. Okay, so I'm just gonna write all the quantities as coefficients. All right, then we have iron chloride. It's aqueous, so what does that mean? Dissolves. How many irons are there? 2 irons. And did we already determine the charge?
Yeah.
Okay, so I know it's a 3+ charge. Okay. Then next is chloride. How many total chlorides are in this formula?
6.
Okay, 6. 2 times 3 is 6. So then there's 6 chlorides. All right, calcium chloride is aqueous. So what does that mean? Okay, it dissolves. How many calciums? Okay, 3 calciums. How many chlorides? What's 3 times 2? Okay, so 6 chlorides. And then next, we have the iron hydroxide, and it's solid. I am running out of space, so I'm going to write it down here. Because it's solid, you keep it together. Okay, you with me so far? Yep, thank you. Keep it balanced. Okay, next step, what are you going to cross out? Okay, cross out those spectator ions. So you have 3 calciums with a 2+ charge, 3 calciums with a 2+ charge. Are they identical? Yes, so you're going to lightly cross those out. All right, you have 6 hydroxide ions. You have hydroxide bonded. Are those identical? No. Okay. 2 iron ions, iron hydroxide. Are those identical? Okay. Nope. 6 chloride ions, 6 chloride ions. Are those identical? Yes. So if they're identical, cross them out. All right, so then that last step is the net ionic. So the good stuff, you're just going to rewrite everything you have that didn't get crossed out. So we should have 6 hydroxide ions plus 2 iron ions. And it should give us 2 FeOH3. And then since we already balanced everything in our first step and we kept it balanced down here, this should automatically be balanced for you. Okay. So we have 6 hydroxides. What's 2 times 3? 6 hydroxides. 2 irons, 2 irons. Okay. And then charges should also balance. So there's 6 negative charges. And then what's 2 times 3? 6 positive charges. Do those negatives and positives cancel out? Good. Okay. So if you take the time to balance up here, and if you carry out that balancing down here, this should automatically come out balanced.